Okay, here we are, chapter 7.2, right triangle trigonometry. We are on page 6 of the notes. First things first, exercise 9, continuing what we were doing on page 5. Trig function is always equal to the cofunction of its complement. So 9a, let's find the complement. And so that's 90 minus 23. Our complement is 67, which means the tangent of 23 is going to be equal to the cotangent of the complement, which is 67, and the little degree's not in the right place. So for B, same thing, we've got a 51 degree angle. The complement then is 39 degrees. And so this time, the function itself is not filled in, but we're talking about cofunctions. So the cofunction of cosine is sine, just the function part. So this is equal to the sine of 39 degrees. C looks more complicated than it is. You notice both the sine and the cosecant have the same argument. It's that pi over 6. And so what we need to remember here is that cosecant, so let's go sine of pi over 6, cosecant is 1 over the sine of pi over 6. Sine of pi over 6 over sine of pi over 6 cancel each other out, and so we end up with just 1 there. D, we get the sine of 3 pi over 8 minus the cosine of pi over 8. I do want to confirm that those are complements off the top of my head. I don't have all those radian measures multiplied. We get 4 pi over 8, which reduces to pi over 2. So 3 pi over 8 and pi over 8 are complements. That means the sine of 3 pi over 8 equals the cosine, its cofunction, of the complement pi over 8. So these two, sine of 3 pi over 8 and cosine of pi over 8, actually have the same value. So when we subtract those, we get 0. Okay. Same thing on exercise 10, just a couple more. The cofunction of tangent is cotangent. So we're looking for the cotangent here. The complement of 40 degrees is 50 degrees. 50 plus 40 adds to 90. B, again, a little more work. So we're on 10B here. I need to find the complement of 3 pi over 4. So I have pi over 2 minus 3 pi over 4. We need to get that common denominator so that we can subtract these. That gives me a 4 pi over 4. Back that up. Gives me a 2 pi over 4 minus 3 pi over 4. Notice that when we subtract those, we get a negative pi over 4. Sometimes that happens. So cofunction of sine is cosine. Here the complement of 3 pi over 4 is negative pi over 4. Same thing on 10C, just randomly changing colors, no big deal. We got 90 minus 105.6. We get a negative 15.6 degree angle. So we have cosecant, the cofunction is secant, negative 15.6 degrees. Last one, 10D, 2 pi over 9, that's definitely less than pi over 2. So I got a pi over 2 minus 2 pi over 9, and I'm going to make some of you crazy and just randomly change back to the blue. Times 9 times 9 times 2 times 2. We get 9 pi over 18 minus 4 pi over 18. So the complement is 5 pi over 18. Secant, the cofunction then is cosecant. We got the cosecant of 5 pi over 18. So now the bottom part of this is not meant to be super intimidating. These are our function identities. Please don't overthink this. If the angles are complementary, that just means one angle, we're going to call it x, plus the other angle equals that 90 degrees, which means then we could solve for x, we get 90 minus theta. If we are in radians, we got that x plus theta equals pi over 2. So then our angle x is just pi over 2 minus theta. Because that's all that we've got going on here in the arguments. Yeah, so all we're saying is that the cosine of the complement equals the sine of the angle. And the same thing over here, if we've got it written in radians, cosine of the complement equals the sine of the original angle.